Welcome to the video to help with the practice problems from lesson 10-3 on solving exponential equations by rewriting with the same base. This video is going to cover problems 1, 2, 3, and 4 from the back of the notes page. If you need help with 5, 6, 7, or 8, please click on to the next video. Let's get started. The directions state, practice. Solve the following equations by rewriting with the same base. Starting with number 1, right, we can see here that we have 4 to the power of x plus 3 equals 4 to the 5th. And as we start here, we can see that both of these have bases of 4 and they both have exponents. So when we have the same base already, we don't need to change anything. All we're comparing is the exponents, right? We need to think about it as what number added to 3 is going to give us 5. Or we can even just set up that equation, x plus 3 is equal to 5. We finish solving it, and you see we've got x is equal to 2. And that is our answer for number 1, but we can always take it and check it, right? If we take it and we plug it back in, we have 2 plus 3 in our exponent on the left, and then we don't even have to change anything on the right, and we get 4 to the 5th is equal to 4 to the 5th. You don't even need to know what 4 to the 5th is, we just know that both sides equal that, so we are good to go. Let's move on to number 2. This one, we have 3 to the power of 2x plus 1 equals 3 to the 3rd power. And again, very similar to the first one, right? We can see that we have the same base on each side already, so we're comparing the exponents. Let's go ahead and pull those exponents out and solve the equation. So 2x plus 1 has to equal 3 in order for this to be a true statement. Let's just set those equal and solve it. We've got 2x is equal to 2, and when I divide each side by 2, x is going to equal 1. So let's take that here and let's check it. Let's plug it in. Right? We have 3 to the power of 2 times 1 plus 1, and that should equal 3 to the 3rd. So 2 times 1 plus 1 is going to give us 3. We end up with 3 to the 3rd equals 3 to the 3rd, and we don't even need to go any further because you can tell that that is correct already. All right, number 3, you're going to see that this is the point where we actually have to start thinking about changing bases. Okay, so this one here, right, our bases are not the same. So remember, we want to look at the one that has the greater base, first of all, and say, hey, can this one be rewritten as the smaller base? So in other words, can 9 be rewritten as base 3? 3 to what power is 9? Right, we know 3 to the 2nd power is 9. So let's substitute that expression in for our 9. We've got 3 to the 40th power is going to equal, instead of 9 to the power of x, we're going to say 3 squared to the power of x. Now we're going to apply our properties of exponents, right? When we raise a power to a power, we multiply. So we've got 3 to the 40th power should equal 3 to the power of 2 times x, and we'll just call that 2x. And now you'll see they have the same base, and we will just set the exponents equal to solve. So divide each side by 2, we get 20 is equal to x. That should be our answer. And we can check it, right? Let's say we've got 3 to the 40th power. That's going to be a big number. And then we're going to say 9 to the 20th power. Are these two things the same? So let me see if I can grab my calculator out. I had it open. Let me find it here. I'm just going to use Desmos. So for this one, we'll say 3 to the 40th power. Right, that's a big number there. I don't even know if I could pronounce that one there if I had multiplied it all the way out. But let's just take our second expression, our 9, and we're going to raise it to the 20th power and see if we get the same thing. And you see there's evidence that they are the same. So we know that it is correct. So we'll just say that these are equal. That's a big number. We don't need to write it all the way out. All right, so let's look at number 4 now. 4, we have 2 to the power of x plus 2 is equal to 8 to the power of x. And again, These ones do not have the same bases, so let's look at the bigger base and say, can we rewrite that as the smaller base? So in other words, can 8 be rewritten as 2 to some power? Think about 2 times 2 is 4, times 2 gives us 8. So 8 is the same thing as 2 to the third power. Let's substitute that in for our 8. So we're going to say 2 to the power of x plus 2 should equal, instead of 8, it'll be 2 to the third power, and then we're going to raise it to the power of x. Now we've got 2 to the power of x plus 2 equals 2 to the power of 3 to the power of x. Remember, we're going to use our exponent properties, so we're going to multiply those together. We've got 2 to the power of 3 times x, or 3x. And now that we have the same bases, let's just take it and set our exponents equal. X plus 2 is equal to 3x. Need to get our x's together, so we'll subtract x from each side. 2 is equal to 2x. Divide by 2. So we get 1 is equal to x. So it looks like x equals 1, and we can just check it over here. We've got 2, we're going to substitute 1 in for x, so 2 to the power of 1 plus 2, right? So that's like 2 to the third power, which is 8. And then let's plug in the 1 on the other side. We have 8 to the power of x would be 8 to the first power, and we know that equals 8. So we can move on pretty confident that our answer is correct, x equals 1. If you have additional questions on any of these ones, please reach out, let me know. The problems 5, 6, 7, and 8 you will find in the next video. Good job. Thanks for watching.